my lecture today. Of course, today, um, let me just say specifically, this week is last week of lecture, and by tomorrow, I'm going to release final practice questions. Okay, and of course, your midterm too will be graded. We're going to start the grading from today. So we are starting the final chapter the semester that I call chapter 6, function of random variables. And let me say that because there's a connection between what we want to do now and the joint probability distribution, I'll quickly summarize. Uh, the bivariate normal density. I'm going to revisit that once again because there's a lot of connection between the joint probability distribution and the functions of random variable. So, like I said, I'm going to have a summary again. Okay. Now, if S follow normal with this as the mean and this as the variance, okay, and Y follow normal with this as the mean and this as the variance, X plus Y, how is it distributed? Okay, because I just want to say this is a function of random variable as well. So how is X plus Y distributed? If I really want to know how X plus Y is distributed, then I need to know what is the mean of that. What is the variance before I will be able to write the distribution. So here, this is going to be E of X plus E of Y that I'm also going to call this. Here, this is variance of X plus variance of Y plus 2 covariance XY. Okay, now if I want to write that down, I'm going to write this plus 2 this. Okay, now, and don't forget, since the correlation is this divided by this, okay, so this implies this equal this. Okay, so which means in a way here I can do variance of X plus Y equal sigma squared sigma that plus 2 instead of the covariance. I can express that as this. Now, what I'm going to say now, I'm actually going to say, therefore, X plus Y follow normal distribution, okay, with the mean of this, okay, and this. Now, from the distribution of X and Y, I was able to write the distribution of X plus Y. So similarly, I can also write the distribution of X minus Y, which is going to be this. Okay? If you take a look at that. Okay? Now, you remember the other time that I said that if X equal maybe sigma equal, let me just write equal this, and Y equal sigma Y, into Roy Z1 plus square root of 1 minus this V2 plus mu2 situation where if sigma y equal to 1 and mu2 equal to 0, okay, if mu2 equal to 0 and sigma y equal to 1, you're actually going to have this. You're actually going to have this guy here. If I call this equation 1 and call this equation 2, do you know that based on what we want to start today, from this and this, we can derive the probability of the joint. We can derive f of xy. Okay, we can derive of xy. So after I'm done, like maybe tomorrow, I'll revisit here, and if I make use of equation 1 and equation 2, okay, I'm actually going to get what we did before. Okay, I'm just trying to let you see the connection. Now, by the time, so with this and this, we can actually derive this. But as time goes on, you're going to see how that is going to play out. Now, my final review before I go into that is that you now know that expected value of y given s equal to this is mu y sigma y rho x minus mu s days. Okay, and you know the variance of y given that is sigma squared 1 minus this, and of course I told you f of y given x equal to that, we're actually going to have 1 over square root of 2 pi, then sigma squared y 1 minus rho squared ESP into, okay, so into this 1, if I have a 1 over 2 sigma squared 1 minus rho squared. Okay, so if I have this guy now, and here I'm actually going to have y minus this particular mean sigma y rho x minus mu s this, and everything is going to be squared. Now, when you take a look at what I have here, you're actually going to see the connection. For instance, here, let me write it here. If you compare the two, if you compare this, now, if you compare this very one with this, here, the variance is sigma square y. The mean here is mu y. But if you take a look at the conditional, anything other than 2 pi is the variance. So which means for this is sigma squared y 1 minus rho square. That is what you see here. And here, we said y minus mu y. So here's going to be y minus, that is the conditional mean. Then we squared. Okay, now since you understand that now, we're still coming back to this. This topic will still take us back here, probably tomorrow or next. Okay, now I want to welcome you to the function of random variables. And let me tell you this. If X is a random variable, okay, and Y depend on S, okay, and we're seeking, if I know the probability distribution of X, how can we derive the probability distribution of Y? It's just like maybe S has to do with, let me just say, the numbers of hours that we use in a company to generate to produce, and that vary, and the cost, maybe the cost of production is Y that depend on S. If the hours varies, then the cost also going to vary. So if I know the probability distribution of time, can I figure out the probability distribution of the cost? And that's what we want to do now. We got three methods. If you want to do this, one is the method of